Today, we completely pivot, although not completely pivot away from databases. Um, First of all, for the 565 students, there is a project, database project, that is now assigned. And it's not very difficult, I have learned over the years. It takes about a day to do. So it's not something that will take forever. It's probably comparable to a homework assignment. But you need to get to it. So it is due on the 30th, so the end of the month. And you then have until the 12th to demo it with Matt. Okay, Matt might extend it if he has still some issues to deal with, but that would be up to Matt. At any rate, you will be demoing it with Matt, but the link tells you what you need to do, what write-up you need to provide. So I think it's pretty clear because at this point, there's been several iterations of it, and I've always, as questions came in, tried to update the write-up. So I think that's pretty clear. So again, something that you need to get to, but not something to stress about because it's not going to take up oodles and oodles of your time. But you do have to remember that it is now assigned and is due on the 30th. So it's basically doing a database from scratch. Okay. So the class now pivots to doing web programming and web programming and scripting languages. We'll be doing that for the rest of the semester. It also pivots in that for the remainder of the semester, you're going to be working on a project. There's only one homework assignment for the entire rest of the project or course. That's toward the very end, way at the middle of April when we get to JavaScript. There is a homework assignment that involves something with JavaScript. Otherwise, what your assignments involve from now on is that you're going to be working on a web project. If you're an undergraduate in 465, you may work with a partner. If you are a graduate student, you must work by yourself. Okay? So there has to be a difference in the, basically, if you're a graduate student and think this sounds unfair, the reason is the university requires in a combined course like this that the coursework for graduate students be more demanding than for undergraduate students. You cannot get graduate credit for undergraduate work. So that's why you have a database project. That is why on the first exam you answered a different set of queries. It is why you have to work by yourself rather than with someone else. Okay, so the university requires I guess a higher level of work and effort for graduate credit. So again, undergraduates may work with a partner. Graduate students must work alone. If you're an undergraduate, you may feel free to work alone. I know when I was a student, sometimes I'd prefer to work alone rather than work with someone else. That's fine, but you're free to work with someone else. So this web project, I haven't yet got the description together because essentially it was too difficult when I gave it 2 years ago. So I have to simplify it a little, and I'm in the process of doing that. Let me show you what that is going to look like. You're not going to be quite this sophisticated, but we actually have a, well, let me get it up first, and then I forgot to do this ahead of time, so I will do it now. This is where it gets annoying. Where is that thing to boot it up? There we go. Don't need to learn more about you. I know what you are. Start the servers. And so you'll have a login. Actually, I should have gone back. So you will start just like I did, but I'll get back to it. So basically, in this department, and in fact, every engineering department, we are ABET accredited. There's an accrediting organization called ABET, and every 6 years it comes and they send a team to evaluate us. And in between, what we are trying to do is improve student achievement. So we have actually listed a set of ABET goals. So if you go to the right web page, you can find that for each of our 3 undergraduate programs, we have a number of student outcomes that we expect you to attain by the time you graduate. So most of you are CS majors, so there's 6 for you. We want you, for example, to be able to analyze a complex computing problem and apply principles of computing and other relevant disciplines to identify solutions. ABET requires us to assess how well you are attaining these student outcomes. And so we have courses where we assess the various outcomes. I think 360 and 302 assess this particular outcome. So what happens at the end of the semester, we send out the assessment committee, sends out email to professors of those courses, and it asks the professors to rate how students have done on the outcomes that that course assesses. So for example, the 302 professor has to, for each student, say how well that student accomplished this outcome. And we have 3 outcomes that, so for example, I don't have 302 here, so I'll take 365 instead, and they enter results. So in this case, the outcome, there's only one outcome, and it is outcome 2, design, implement, and evaluate a computing-based solution. So if I was the 365 instructor, I would be expected to input the number of students that exceed expectations for that outcome, meet expectations, and don't meet expectations. Okay, so I would, in this case, I entered 80, but I would enter some number, and as you can see over here, it totals it up, and at the end I save the results. In addition to giving the number of students that meet each outcome, so let's do a different one that hopefully has more outcomes. Nope. How about this one? Here we go. So sometimes a course has to deal with multiple outcomes. So in that case, I would look at this. Some of you don't seem to be looking. Hello, those of you who aren't looking, I don't want to go over this again in another week. Okay? Please look at this because this is what your project is supposed to look like. I'm going over it because this is what your design is supposed to look like. I don't want to hear questions in 2 weeks about what my project is supposed to look like. I'm showing it to you right now. And you can't log into this site, okay? Only professors can log into it. So it's not like in 2 weeks you can log into the site to see what it looks like. This is your one and only opportunity to see what this looks like. Okay, so you better follow along right now because this is it. This is what it's supposed to look like roughly. Okay, so You have multiple outcomes, and they're in these little boxes that you can increment and decrement. Okay, we'll get to how you create these kinds of boxes. You can also enter a number into them. Okay, then in addition to entering this, which is essentially a table, you have a plan. Okay, so every professor has to say which assessments, like homework, exams, reports, quizzes, they use to evaluate this outcome, and what percentage weight they apply to it. If this looks a lot like computing a grade, it is a lot like computing a grade, except the grades are 3, meets expectations, exceeds expectations, and not meets, rather than A, B, C, D, and F. So they have to say which assessments they used, what the weight was, and the weight has to add up to 100, and a brief description of the assessment. So if you're taking the senior design, you have a project. So we're saying in this case that 50% of the what determined whether you exceeded expectations for outcome 1 was the project description you handed in, and 50% was the project implementation. Okay, for CS465, okay, I was trying to do some testing to mess things up, but labs 1 and 6 were 60%, the project was 15%. This is just me testing, trying to break my website by using some stuff. So this was me actually acting like a hacker to try to break my program. But the professor provides a description of the assessment and the weight. And that adds up to 100. They can add new assessments. So if they say plus new, they can add a new assessment. Okay, so I might say midterm 1 question on Java. They can also remove things by hitting the trash icon. Yes?
Will it let you save it right now since it doesn't add up to 100?
So I think right now it does, and that's because my program doesn't currently check to see whether it adds up to 100. Okay, I haven't decided yet. Okay, so that's why the write-up's not yet available. The last time the answer was yes. I have to figure out how much to pare it down. Okay, so all of that will be up by the end of the week. So maybe the answer is yes, maybe the answer is no. Okay, there is an easy way to test this. Okay, and that is using the grouping operator. So you can easily check by doing a sum on the weights for the database, and it should add to 100. So that's why it may very well be in there, because it would force you to use a aggregation query. So that's why I'm thinking of saying the answer. I'm leaning toward yes. Okay, and I think that my site currently doesn't check that. So I'd be adding something that you didn't. But I believe it's saving every single time that you remove or add right now. Okay, so you will have to be able to add a new, again, this is a table. So basically it's the ability, new adds a new row, delete deletes a row from the table. Okay? And there's a back-end database that's storing all this information. I will give you the relations. Okay? And I will give you some sample data. You will be giving me an ER diagram as part of the initial project assignment, because it's good practice to write ER diagrams. So I'll give you the relations. You're going to give me an ER diagram. Okay, and then there's a final thing, which is the narrative. So for each outcome, they have to tell us what the strengths, weaknesses, and actions are. So strengths are what students did well, Weaknesses are things students did poorly on that particular outcome, and actions are suggestions about to the next instructor on how to improve the outcome. Okay? We're not converting 365 to functional languages. This was me just testing. So these are actions that the instructor suggests, and these are just text boxes. Okay? So essentially, what you are going to do is you are going to have a sign-in page. So I'm going to log out. So you're going to have a sign-in page that looks a little like this, where the person enters their email and their password, and you check to make sure that their ID and the password is in your database. And if it is, you log them in. And if it's not, so foo is not a legitimate thing, please enter an email address. Means it's not valid. Incorrect email or password. The password wasn't valid. Actually, this is not a valid email, so it's not even going, so it's using a filter. And we'll get to all of this, how you do it. Don't worry if you don't know how to do it now. That's part of what we're going to cover. But right now it's saying please enter an email address because this is not a valid email address. Okay. That is a valid email address, but it says incorrect email or password because that particular email is not in the database.
Is there supposed to be a sign-up page as well?
Nope. So to make your life easy, and in fact, this is in fact real, we do not have a sign-up page. We enter the professors and their information. You will notice there's an admin down here. You don't have to do the admin, but there's an admin where we can add new users, give them a password, kind of like IT staff. Okay, so this is actually by invitation only. So you will assume that the instructors are already in the database. Okay, so then when the instructor logs in, you have to find out which sections they're responsible for providing feedback about, and you'll put that into a little pull-down menu like this. Then when they click on the course, you are responsible for showing the results page and showing this table with these 3 columns. And then you will also be responsible for, I'm not going to make you responsible for the tabs. This is a little too complicated, so that's another thing I have to figure out is how not to force you to do tabs. So I'll probably have you do links over here. So you'll probably have a links with outcome 1, outcome 2, outcome 3, and when you click on the link, you would see this page. So you'll have to do a table for the plan, and you'll have to do something for the narrative. Okay, so that's what your web interface is going to look like. There are questions about this. I'll try to give you some screenshots, but this is, you're not going to be able to play with it. Okay? The actual system is a production system, and it contains information that is probably confidential. So we can't have you playing with it. And what I have here is on my local machine. I'm running something called MAMP, which you should not have to do. You should be able to do this on the department's computers. I'm just running MAMP as a server on my own personal laptop. It takes a little bit of work to get MAMP to work. I don't suggest you try to do it unless you already have some experience with server stuff. Okay. At any rate, you'll be able to do the project on the Hydra machines, or should be able to do them on the Hydra machines. Okay, so it's relatively simple In terms of navigation, there's the initial web page. Also, you're going to have a way for them to log out. Okay, you're not going to have a user. The user profile right now gives a way to change the password. I'm not sure yet whether I'm going to have you do that or not, but you definitely will have a logout command so that they can be logged out. Okay, so there is a back-end database that keeps all this going. So I will provide a nice write-up for it, but here's all the relations. So for example, there is a relation for the assessment plans. There is a relation for the results. So if we look at that, you can see there's a section ID. Oops, that's the description of it. There is a section ID. There is an outcome ID, the outcome major, the performance level, and the number of students that got that particular performance level. Then if I go to performance level, you can see that, oops, where is it? Browse. You can see performance level 1 is mapped to not meets expectations. Performance level 2 mapped to meets expectations. So you're still going to be doing database stuff in the second half of the course because there's a back-end database that is containing all this information. Here is users, browse, first name, last name. Oh my gosh, you don't get to see the password because it's encrypted. Just blows me away that sites routinely don't use encryption on their passwords. It's just ridiculous that they don't use encryption because it's so simple to use encryption for passwords. Anywho, you can, however, see that if you crack the password, they all hash to the same thing. It's because you're supposed to change your default password, right? Okay, so at any rate, here is that. So user ID 12, and here's a section. So user ID 12, here was 365, ID 8. Here's an instructor section mapping. So here is me, section 8. Here's my user ID 12. So I was teaching section 8, and you can see that section 8, that's not it. Is this it? Yep, section 8. And that's not it. Where do we get? Well. It's not there. I'm trying to find something. Sections. There we go. So we can see that CS365 in the spring. Do we not have CS3? There we go. Spring of 365. CS365 was doing outcome 2. And under sections, we see that 365, spring 2019, was section 3. And we can see that section 3 was taught by user ID 12. So there's a lot of joining that you're going to be doing. You're going to be doing lots and lots of joins to find information that you need. Okay, so Yes.
Will we have access to a GUI like this, or will we be using the command line like we have been for the SQL?
You're going to have to use the command line. Again, if you take the time to install MAMP, and it took me, if I remember correctly, about 3 or 4 hours, and there were some 4-letter words uttered during that time, so let's just say that there was a lot of irritation and anger that went along with that's why I'm not suggesting you try for MAMP, because I talked to Marcus. This tool is available. He is worried that there are security issues. Okay, so he doesn't
We're not
want.
setting it up, so I'm sure it's
Well, you're going to have. So what I'm going to do is give you some sample data. I'm not going to give you total sample data for it. So you're going to have to do some inserting on your own. Okay, because again, I want to give you some experience with generating test data.
but not in the relationships, only in the actual testing. Right?
Yes.
Yeah.
So you're going to have to write some scripts that basically SQL scripts that do insert into. I'm going to give you an initial script that gives you a bunch of insert intos. You're going to have to write the create tables. So I'm going to give you example data, and I'm going to give you relations in the form like outcome, say outcome ID, say description, say course, and then I'll give you some example data, and I'll expect you to do the create table commands. Okay, so be some more practice with DDL. Okay, if you have questions, you're free to ask me. Generally, you should be able to figure out from the example data what the type is, but if you really can't figure it out, you can ask me. So, but I'm going to give you the relations like this. I'll give you the name of the relation, the attributes. Then I'll give you some example data. You need to write the DDL and populate it with additional test data. And your first assignment, essentially, I'm going to give you a set of queries that you need to write, because eventually you'll need to write those in the back end. Okay. Yes.
So you said that you recommend writing these in the Hydra sheets.
Yes.
Does that mean once we get to like the GUI part, we have to be on campus to work on it?
No.
Just use, like,
You can still do, so you have a web home directory.
Okay.
And you should be able to put your stuff in the web home directory, and then it should work. So essentially you're using our machines as the server. Okay?
So regarding when this is due, is this like, is there a set of things that are going to be
Yes.
due?
So, okay. So let me get to that. Any other questions about what I've just covered? Okay. So there's going to be a series of intermediate deadlines. So the first one is basically going to be your database design, where you give me a DDL, you give me an ER diagram, and you give me the test data that you've come up with, and you give me a set of queries that you've written. Okay, and I will tell you what the queries need to be. I will say, write a query that returns that given an instructor email address returns the set of section IDs that, so it'll be like the exam basically. Here's a set of queries, give me a set of SQL queries. Okay. This is basically like a homework assignment. You'll have the whole month to do it. Okay. And you already know how to do all this. Okay. So the first month is essentially just getting the back end set up with the database. Then in April, you're going to have to convert these queries into PHP. Okay, and I think it's going to be due April. I have to probably change the deadline a little bit, but there's a second intermediate deadline where you have to write some PHP. And then there's the final deadline at the end of the semester. Okay, so basically what I've learned is if I don't have intermediate deadlines, too many of you put it off to the last week. This way, by having intermediate deadlines, you get stuff done. So you're not going to really be able to do the graphical interface until the very end. Okay, that's one thing I learned from last time, is trying to make you do the web interface at the beginning doesn't work very well. Okay, so by the end of the week, I will have a write-up, and I will have the first homework assignment, the first project assignment ready, and like I said, it's going to be due on the 30th. This may look like more time than you really have. We have spring break in here, and generally I do not try to make you do work over spring break. So I'm not assuming you're going to be working on this over spring break. So that's why the extra time. You don't have to tell us if you're working in a pair just when you do the first submission. Again, this will be written up, but I just want one person to do the submission. If you two are working together, don't both of you submit. Just one of you submit, and then in the comments say, I'm working with such and such. Okay, and then we'll give that person a 0 and you all the credit. No. Okay, so questions about that? Okay.
I did so all the time.
Now, also, good news. The second part of this course is, for the most part, easier than the first half. In fact, there are days like today where I consider it to be quite easy and not really worth my lecturing a whole lot, okay? Because honestly, it is easy. You can read how to do it. And I will just have you do the after class or in-class challenge activities here while you're in class. So I can help you if you do run into a problem. There are times when I will have lectures. So it turns out that regular expressions tends to be a pain in the neck for everyone. So it helps to have generally a complete lecture on that. It seems like form management tends to also be a bit of an issue for people. So there will be times when I lecture. There will be other times when I basically simply talk for a few minutes and then I say, get to work. Okay? But I do expect you to show up. And the reason is, if you get things done, the in-class activities, then I want you to work on the project. Okay? That's a way to also get you moving along and having me here so I can help you. Okay, so starting on Thursday, am going to make attendance mandatory. Okay, so I expect you to be here. And you will finish the in-class activities if you get the in-class, or you will work with your partner or by yourself on the project, one or the other. Okay, and I'm here to help. Okay, as I said, sometimes there'll be a lecture, sometime it will be very brief. Okay, so that's the way it's going to work the rest of the semester. You will note that there are now these challenges in the book. So those are things that are a bit more difficult than the participation activities. They're more like coding. So those you'll either complete in class or before the following class. They take the place of the quizzes. So you didn't like the quizzes maybe, now you'll be doing these challenge activities. When the book eventually gives up on the challenge activities, it's back to quizzes. But that's not for a while. I think at the end of March, you have a couple quizzes. But for the time being, you're doing challenge activities, which are a little more difficult than the pre-class. So before class, you do the pre-class participation activities. In class or after class, you do the challenge activities. Okay, we good?
When do they usually do the in-class or after class?
The in-class and after class are due by the beginning of the next class. So Tuesday ones are due Thursday, Thursday ones are due Tuesday.
So same as that.
Same as the quizzes. Should be the same as the quizzes. Other. Pardon?
At least the next one seems to be on campus. Like this one's due on Tuesday, or whatever the other day is on noon 30. I haven't checked the one for Thursday yet. But
This one is due when?
Um,
Today's?
Today's is due on the 5th at 12:30 p.m.
Yes.
Yes, so that one's good.
Okay, so that's what I want. So today's You're doing all the challenge activities in 2.4 and 2.5, which are lists and tables. Okay, so you'll be doing those. Other questions? Okay, let me first, I do have a brief lecture for today, and that is just an introduction to things to give you a broad overview of what we are going to be talking about for the next 7 weeks. And interestingly, none of us, okay, have to go to my notes. I thought they were already there. Notes, scripting languages. Okay, so I can pretty much guarantee you there's something on the exam with this, so you should be paying attention. The goal of, so the second part of the course is web programming, and we're going to cover a whole bunch of different types of scripting languages or markup languages. So we'll be looking at HTML, which is used to, well, I'll go over that in a moment. We'll be covering HTML, CSS, which is cascading style sheets, PHP, and JavaScript. And these are all more or less scripting languages that are designed to allow you to accomplish specific tasks quickly without concern for machine efficiency. So compiled languages like C++, Java, C, C#, they all put an emphasis on runtime efficiency. They don't care about your efficiency. So you can blow lots of your time trying to write a very efficient program. Scripting languages turned that motto on its head. They said, we're all about your efficiency. We want you to be able to write the program as fast as possible. We don't care if we sacrifice runtime efficiency. So scripting language programs run more slowly on average than compiled programs, sometimes up to 10 times slower. The original point of scripting languages was that they were done for one-off tasks. So maybe I needed to do a quick calculation of students' grades. I didn't really care about the efficiency, whether it took a second or 5 seconds to calculate your grades and print out a nice report is much less important than whether I can write the program in 5 minutes or an hour. Okay, if I write it in 5 minutes and it takes 5 seconds, that's 5 minutes and 5 seconds. If I take an hour to write it and it runs in 1/10 of a second, I still blew an hour on it. Okay, so the idea was for once off or things that didn't have to run a whole lot, programmer efficiency was much more important. Now, if you're Jack Dungera and you're writing LinPack or LAPack, or you're writing some data science application that requires a lot of number crunching, by all means do it in a compiled language, because that's being executed a lot by a lot of different people and it takes a lot of time. Therefore, runtime becomes a lot more important than your time. But if you're writing a web app where most of the tasks take a split second, whether it runs in a microsecond or 10 microseconds is pretty immaterial. Okay, these tasks are very short in general in a web interface. So there, programmer efficiency is everything. So how do scripting languages achieve this goal of being much more efficient with respect to your time? The biggest thing is economy of expression. In fact, almost everything else on that list follows from economy of expression. Basically, they are trying to allow you to write a program with far fewer lines than you would be required to write for a compiled program. Okay, so they accomplish this in a number of ways. First of all, scripting languages in general don't require you to declare your variables. You can, but they don't require you to. So essentially, the whole part where you declare a variable and its type goes away. Okay? How then do they type the variables? They use dynamic typing. Whatever value is assigned, the type of whatever value is currently assigned to the variable is the current type of that variable. Okay? We are not going to cover Python in this class. We cover it in 365 and in some of the upper level courses, but it so happens that it's got a command line interpreter and is a good illustration. So I don't declare A, I assign it 6. It's now an integer variable. Now it's a floating point variable. Now it's a Boolean variable. Okay, now it's a string. So it uses, well, actually, just to show you that, hi Brad, it's a string. Okay, so scripting languages use flexible dynamic typing. Okay, so there is a, whatever value is currently assigned to a variable, that is its current type. We're not really going to be too concerned with easy access to system facilities, but most scripting languages give you an easy way to make a new directory, change directories, list the contents of the directory, run a system command. Okay, and they do it in a system-independent way. The way that you list the file contents in Unix is what? The contents of a directory, sorry. ls. What about on Windows? dir. So it's different on different platforms. Scripting languages introduce their own command for listing the contents of a directory, and then you'd use that command and it's portable to whatever operating system you're on. Okay? So Perl, I think, uses dir, D-I-R, and whichever platform you're on, dir returns a list of the current files in the directory. Again, we're not really going to worry about that in this course because we're more interested in how scripting languages are used with web interfaces. If this was a class on information technology, for example, if I was trying to teach you how to become part of our lab staff, I would be much more interested in the easy access to system facilities because our lab staff, I believe, makes extensive use of Python to do a lot of its programming. And that's because it gives access to, easy access to the Unix and Windows systems. Okay, the next thing is sophisticated pattern matching and string manipulation. So the ability to search files for information is very important with a lot of scripting languages. For those of you taking data science, the ability to efficiently search a big text document for, say, things that match a date, very important. That's difficult to do in a compiled language, and we make use of something called regular expressions in order to do our searching. So for example, in a scripting language, you can write a pattern that maybe looks like \d 2 /\d 2 \d 4, and this would be a pattern for a date of the form month, month, day, day, year, 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 year. Okay, you can make that more flexible because often dates are of the form like that. So then you could change this to 1, 2, 1, 2. I know that's not easy to read. 1, 2. And that would say between 1 and 2 digits are allowed. So you can write, and the \d indicates it's expecting a digit from 0 to 9. So you can write very flexible patterns that match. Here the backslash literally matches a backslash. This matches the MM. This matches DD. This matches the 4 Ys. So you can get you would match any date that looked like that was in this format. And a scripting language, for example, would allow you to iterate through each date in a file and do something with it. Okay, so this sophisticated pattern matching and string manipulation, very handy. String manipulation, in Europe, they go with day, day, month, month. It's reversed in Europe. So it provides easy ways where you could search for a date like that and replace it with a date that looks like that. So that's what we mean by string manipulation. You can very easily move around portions of a string. Or a database like SQL expects the format YYY dash, I think month month, dash DD. So you could, again, take a date like that, rearrange these components into something that looks like that. So sophisticated pattern matching and manipulation. Then built-in high-level data types. So lists and hash tables are built in. You often hear hash tables referred to as associative arrays or dictionaries. Okay, but these are built in. And they have built-in operations. So in Python, this is a list. Very nice. Okay, I don't have to, I just put it in those square brackets. I can say ace of 2. Okay, I can insert, of course, I'm rusty right now with my Python, so I can't. Let's see. It's probably pop A maybe. Nope. As I said, I'm rusty. Okay. So, pardon? There we go. So A is now down to 3 and 6. Thank you. And it returned the last one. So there's built-in operations. They're actually implemented as arrays. I found this out a few years after I started using Python. So actually inserting into the middle of them is easy and inefficient. What is it? Thank you. Okay. Told you I'm rusty. I used to be a Python whiz, but now I do all my programming in PHP and JavaScript. Okay, you can do things like array slices. So that returns the elements starting at index 1, going up to index 3, but not including it. There's all kinds of cool things that you can do. Okay, they also have very succinct syntax. So if I want to iterate through the elements in A, I can say for x in A, print x. Much simpler than writing for in C++. That would be for I equals 0, I less than a dot size, I plus plus. Then I would need cout ace of I. And I know I could use in C++, I could use the for range loop, but I'm just pointing out how the syntax tends to be more succinct in a scripting language than it is in a compiled language. Okay, and then finally, scripting languages are interpreted. rather than compiled. So they run much more slowly because of that, but every time you want to run your program, you don't have to go through a compile and link step. Okay, compile and linking takes time, whereas interpreted programs you can just run immediately and they start executing immediately. The other thing about interpreted programs, you don't have to shut them down when there's a bug. You can actually just fix the bug. So you find that a pointer is null, you simply set the pointer to whatever it was supposed to point to and let it continue. Now, obviously, you should probably try to fix what the problem is, but the point is you don't have to shut down the program just because there's a bug. You can actually fix it and then start the program running again. It also, by being interpreted, lends itself to rapid prototyping. I can very quickly change, say, the color of objects on a screen, and we'll get to that. JavaScript uses something called a prototype instance model where the prototype controls the appearance of all the other instances. If you change the color in the prototype, all the instances immediately change. And you can't do that easily in a compiled language, but you can in an interpreted language. So you can very quickly change properties of an object or a prototype object, have that property immediately propagated to all instances, and all of a sudden your interface changes. And that's very helpful when you're doing user testing. You can say, do you like, you know how at the optometrist, can you see that better or that better? Same thing with user testing a graphical interface. Is that easier to use or is that easier to use? Well, if you have to shut it down and recompile it, that can take a long time just to change one property. But if instead all you have to do is go to the command line, change one field in one object, and all of a sudden the entire interface changes, that's pretty neat. And you can go back and forth very quickly, so the user can easily compare the two. So scripting languages, by being interpreted, lend themselves to rapid prototyping, something that compiled languages don't. Okay? So I love using scripting languages. Now when I have to use compiled languages, I definitely find they get in my way. There are other people, Dr. Plank, who maybe doesn't feel quite the same way about it. Although I think even Dr. Plank is coming around to Python. Slowly but surely. So, but there are things that are really wretched about it, such as the fact that Python uses arrays for lists without telling you that fact. Just very devastating to the efficiency of your program if you don't know that Python lists are implemented using arrays. So there is sometimes very good reason to be Python. Let me put it this way: if you're scripting languages give you a lot of rope, and you can use that rope well to, like a cowboy, to lasso a steer, or you can use that rope to hang yourself. Okay? So you got to be careful when you create that lasso, you get the right thing, the right neck. Okay? So that's what I'm saying with things like it being very high level. If you don't realize that Python is using arrays and you start doing some compute intensive thing and treating it like a list where you insert in the middle, you just hung yourself. Okay? Python is doing garbage collection. So does Java and some other compiled languages, but not all compiled languages do garbage collection. But it's very easy in Python and other languages to not realize how you are creating objects willy-nilly. And your program runs slowly because you don't realize that stuff doesn't come for free. When you create a list, that's not for free. It actually creates an object. Okay, so you got to be careful about that. And if you are writing something that's compute intensive, you should definitely think about using a compiled language. Okay? For example, because a scripting language doesn't have type information at compile time, it has no idea whether this plus means integer addition or floating point addition or string concatenation or something else. A compiled language knows the types of B and C and can emit a machine language instruction for integer add or floating point add or something with string concatenation. A scripting language doesn't know until runtime what the types of these two variables are, so it's not until runtime that it can determine what type of operation plus represents. So it essentially has to say, if the type of B is an int and the type of C is an int, do integer add, else blah, blah, blah. Okay, so it's having to look at the types as slowing down. Everything is slow in a scripting language at runtime. So again, if you have to do anything where real-time performance matters, scripting languages are not for you. Okay. Last thing for today, to give you an idea of where we're going the rest of the semester. We're going to basically be covering 4 languages. So we have clients, which are users. Okay, these are clients. And then we have a server. So the client uses a web interface, or has an interface. So they're using a browser typically, or a mobile phone, or an iPad, tablet. And for the web interface, typically HTML will be used to describe the content of the page, so the page content. It's a markup language. Then we have CSS, which stands for Cascading Style Sheets, and it is the page layout. So it's responsible for the fonts that the page content appears in, whether it's italics or bold, how the paragraphs are formatted, what the indents look like, what tables look like. They control the layout. Okay. Then JavaScript is used for interaction. Okay, equals interaction with the browser or with the page. So it handles mouse and keyboard events, reactions to mouse and keyboard events. And updates page. So it may change the page content, it may change the page layout based on mouse and keyboard events. On the back end, you have a server language. We're going to use PHP in this course. We're also going to show you how you could use JavaScript on the back end. There are other languages that can be used on the back end like Perl and Python, but you will be using PHP. Why? Because PHP is the most commonly used language on the back end. JavaScript is increasingly being used on the back end, so is Python. PHP is still number 1. I teach number 1. Okay? I always get comments, Dr. Van der Zanden's so old, he still teaches PHP. And I think back, yeah, that's because PHP is still number 1. We don't teach number 3 until it becomes number 1. PHP is still the most commonly used server-side scripting language. JavaScript is still the most commonly used client-side scripting language. So we teach what is the most common. So we will start with HTML and CSS, then we actually will go to PHP on the back end, and finally we will cover JavaScript. So it will basically be 1, 2, PHP will be 3, JavaScript will be 4. There's actually, the server typically is looking at a database, and that's often in MySQL, but it could be in something like Mongo or some other NoSQL. For this course, we'll be using MySQL. We'll be using the databases you were assigned at the beginning of the course. So there's really 5 languages here. You already know the MySQL language, and PHP gives you ways to access the database. So basically what generally happens is the user sends some request to the server. The server sends the request to the database. The database sends some data back to the server, and that data is shipped back to the user interface, which then updates the user interface. Okay? So that is the overview of what we're going to be doing the rest of the semester. Questions? I think you will find this a lot easier than the database part. It's definitely no theory, except for regular expressions. Regular expressions, I guess you need to know a little bit from 311, but they're not difficult. Other than that, there's no real theory or formalities here. It's pretty nice. Okay? So with that, I am going to let you all go for today, but please do remember to do the challenge activities by Thursday. They're not hard. They're just lists and tables today. Also, please remember that from now on, attendance is mandatory. I will post that on the Piazza website as well.